Today is a beautiful day for science. Currently, we're looking at a coronal mass ejection that occurred from actually just north of 3242 between these two regions here, but it's difficult to see it. Apparently, this is it's very difficult to spot it. It took me a little bit to track it down exactly. But we can see here, right there's the burst. Right there. So this is a oh, apologies. So looking at it on 171 angstroms, we can see the loop movement of when this event occurred. But looking at 304, we can see the actual plasma displacement cause a reaction along 3242 more than north, which is why I associated it to 3242 and right there. So this event, kind of a stealthy one, very difficult to spot, but we'll see it again here. Basically, we see the telltale signs of the event, right here, right there. So that's the telltale sign of this event. This is the complication we have when we have filaments and prominences that are outreaching towards Earth from this single perspective, why stereo ahead and stereo behind was so beneficial for the time we had it from a viewing from the side angles. We could see them a little more clearly. Unfortunately, we don't have that perspective anymore, but we still can see by telltale signs these events that we would miss otherwise. And let me pull up here. This is on the stereo ahead, so we can view this event as it occurs. Let me go back. So yep, that's the event in reverse, and here we go. So we have this. Here's the primary. Let's bring you back down here. And this is the stereo ahead. We have a full halo. This event's a full halo on Soho. But stereo ahead is still ever so slightly to our to our left in the orbit, or behind us in the orbit. So it catches that we are actually not the full focus of this event, which is nice. But we can see a full halo on Soho, but you can still, which is why I chose to show this one first, because we can still see that there is a slight point where this isn't showing as clearly. Anyhow, here we go. So here's the event as it proceeds. You can see this is quite a beautiful coronal mass ejection. Now, it's not moving exceedingly fast. This is like a 2-day CME-ish. So we're looking at about 48-hour transverse from the 93 million miles from the sun is from the Earth. But so that's on stereo head's core, and that's the difference. But let's take a look at Soho, and we'll look at C3 so we can get the full scope. And get it straightened out again so we can see the timestamp as well. And by the way, that is Mercury that we're viewing on that little edge over here. I'll put this little dot on Mercury. And here we go. Let's take you back. And so we can watch the event here. And you'll see this is it's a full halo for us here. You can see the slight you can see the slight cloud of plasma, almost like a butterfly showing here, but that's because it's actually coming spiraling towards the camera view, so it looks a little bit slightly to the west, not directly towards Earth, but it is a full halo. And Here's the event. You can see other CME that occurred on the south end there from a small eruption. And there you go. And in reverse. All right, so in summary, we have a coronal mass ejection that erupted from 3242 region. This eruption has sent a CME that is projected towards Earth. We have a full halo, so this will be impacting Earth. This is transversing a little bit slower than the previous one we've had, so we're looking at approximately 48 hours plus or minus 6 hours, meaning that we'll probably start seeing the impact of this solar storm around 0700 to 1900 UTC on 11 March 2023. So that's based on my math. Yeah, take it with a grain of salt, I guess. But that's what we have. Cheers and science on.